Today we discussed about the 10 delta test. 10 delta test is for or to determine the deterioration of insulation, to check whether our insulation is good and bad. If we do the 10 delta test on transformers, so let us now start about 10 delta test of transformer. Transformers has two winding, one is primary and other is secondary. In case if you think about the vector diagram or the connection, so in the primary side we have the three winding R, Y, B. So this is one conductors, and the secondary side also the three connection R, Y, B. So this is the second conductors. In between the first conductor and second conductors, oil has present in the transformer. So oil is the insulation of the transformers or the capacitors of the transformers. If we discussed or think about what is the capacitors. Capacitors has the two plate, and in between these two plate the dielectric medium has present. So in case of the transformers, primary winding is a one plate and the secondary winding is the another plate. So oil is the so if we discussed about the capacitors, so this is the capacitors. Here capacitors has a dielectric medium in between of the two plates. It is the capacitors. If we discussed about the tan delta, then some amount of moistures and dust particles are in the primary and secondary winding and oil. Obviously some moistures are present in the primary winding or dust particle, or secondary winding or dust particle, and the impurities or the dust particle or moistures in the oil deteriorates the angles. As per the diagram is concerned, it is the voltage, it is the current axis, it is the voltage axis, and IC is the capacitive current and VC is the voltage applied in the capacitors. So in between IC and VC the angle is 90 degree for pure capacitors. For pure capacitors we will get the angle of 90 degree in between voltage and current. In the capacitors we know that the current is lead by the voltage by 90 degree. So in case of the tan delta test, if we applied some voltage, some resistive current will flow to the winding. A resistive current will flow to the winding, and that will decrease the angle. So in case for resistive current flowing, the resultant current will be flow IR plus IC. So this is the delta angle deteriorates from the previous one's IC angle. So this was the resultant current previously, and this is the resultant current after the test. So IR plus IC, this is the resultant current, and this is the delta angle deteriorates, and it is also the IR. You can it is the IR. These deteriorations or the displacement is for the resistive current. So the tan delta is equal to IR by IC, resistive current by capacitive current. In if we discussed about the power factor, then the power factor is IR, resistive current, divided by the total current. What is the total current? Total current is IR plus IC. So IR divided by IR plus IC is the power factor. The another name of the tan delta is the dissipation factors. So the percentage of DDF should be less than 1%. less than 1%. If the dissipation factor is less than 1%, then the equipment insulation is better, or for we can use that equipment accordingly. But if the DDF is 1 or above 1, then you have to replace the respective equipments. After use of 25 years or 20, 15, 25 years, if we do the tan delta test, and if we get the tan delta test of 0.6 to 0.7%, so the material or the equipment condition is okay as per the testing is concerned. For transformers above 5 MVA, we done the tan delta test. We done the tan delta test on the GT, GAT, ST, CT, current transformers, circuit breakers, CVT, capacitive voltage transformers, generators, lighting arresters, isolators, cables, motors, rating greater than 6.6 kV. 6.6 kV, but the procedures of the testings may be changed accordingly. We will after the tan delta test, we will get by help of the some updated machines, we'll get the frequency what we are just applying, what is the leakage current is flowing through the equipments, what is the tan delta percentage, what is the applied voltage to the terminal of the equipment which is under the testing, and C is the microfarad is the capacitance, what is the capacitance between the primary and secondary, which equipments we are just testing accordingly, and P is the power consumptions. If we look at the diagram or the waveform here, what is it? It is the current axis, it is the time axis. Current is flowing as per the waveform is concerned. We are just applying this blue color waveform is the reference current, and after testing we get that black color waveform current, so the test object current. These two points are the displacement. These 2 points is the displacement of the angle. This is the displacement of the angle. This is called the delta, phase shift. So the dielectric losses causes the phase shift. As per this drawing is concerned, we can explain this diagram. As per the dielectric losses, what is the dielectric losses in between? The oil is the oil in the oil, it is the insulation, it is the capacitors, and some amount of moistures and dust particles are present in the primary and secondary winding of the oil. So this is the dielectric losses, and for that dielectric losses, this angle shift or displacement will be there. So this is the tan delta. So the tan delta value should be less than 1 for better use. If the value greater than 1, so you have to replace the material accordingly. So today we discussed about the tan delta test and what is the necessity of the tan delta test, and if you are interested to show my video and get some knowledge about the electrical engineering chapter, so please subscribe my channel and press the bell icon for more update. Thank you friends.